What would happen if the sun exploded right now? Would Earth survive? And how long will we have to say goodbye? Welcome to a journey through the most powerful cosmic events in the universe, the supernova. Our sun is the center of life on Earth, providing heat, light, and energy that sustain us. But like all stars, it won't last forever. Every star has a life cycle, and while the sun is not massive enough to explode in a supernova, let's imagine for a moment, what if it could? To understand the impact of the sun exploding, we first need to know how stars work. The sun, like all stars, is a giant nuclear reactor, fusing hydrogen into helium at its core. This process generates immense energy, keeping the sun stable against the crushing force of its own gravity. Over billions of years, stars like our sun eventually run out of fuel. But the way they die depends on their mass. Smaller stars, like the sun, expand into red giants, shedding their outer layers before becoming white dwarfs. But larger stars, those at least 8 times the sun's mass, end their lives in spectacular explosions known as supernovae. Supernovae release more energy in a few seconds than the sun will emit in its entire lifetime. The explosion sends shock waves through space, forging new elements, and even triggering the formation of new stars. But what if our sun defied science and exploded right now? How would that affect Earth, the solar system, and beyond? In the next segment, we'll dive deep into the terrifying chain reaction that would unfold if the sun suddenly went supernova. The countdown to catastrophe begins. The sun has exploded. A cosmic disaster has begun. What happens next? Let's break it down, second by second, as the most catastrophic event in our solar system unfolds. The moment the explosion occurs, an unfathomable amount of energy is released, more than the sun has emitted in its entire 10 billion year lifespan. But for the first 8 minutes, nothing on Earth seems different. That's because light and radiation from the explosion still need time to reach us. The sun, from our perspective, still appears to be shining. Then, at exactly 8 minutes and 20 seconds after the explosion, everything changes. The sun's light vanishes instantly, plunging Earth into sudden darkness. Temperatures begin to plummet. Without sunlight, photosynthesis stops, threatening plant life and the entire food chain. But light is the least of our worries. What follows is a shockwave of devastation, a blast of high-energy radiation, X-rays and gamma rays, surges through the solar system. When it reaches Earth, it obliterates the ozone layer, exposing the planet to lethal space radiation. This alone could wipe out most life on the surface within hours. Then, the physical blast wave arrives, a wall of plasma and debris from the sun's destruction, moving at millions of miles per hour, slams into the inner planets. Mercury and Venus are incinerated instantly. By the time the shockwave reaches Earth, the atmosphere is stripped away, oceans evaporate, and the surface is scorched beyond recognition. Further out, the outer planets experience their own disasters. Jupiter's immense gravity distorts under the shockwave's pressure, and Saturn's rings are scattered. The sun's gravitational pull, once the glue holding the solar system together, is gone. With no force keeping them in orbit, planets begin to drift into the void. But the destruction doesn't stop there. The debris from the explosion travels outward, potentially triggering a chain reaction of cosmic chaos. If any nearby stars are affected, they too could destabilize, leading to further explosions and gravitational disturbances in the galaxy. Could anything survive this cataclysm? Are there ways humanity could prepare for such an event? In the next segment, we explore the possibility of escaping our doomed solar system and finding a new home among the stars. The sun has exploded and Earth is doomed. But could humanity escape before the destruction reaches us? Could we find a new home beyond our dying solar system? The key to survival would be time. If scientists detected instability in the sun centuries in advance, we might have enough time to develop interstellar travel. But if the explosion happened unexpectedly, humanity's chances would be slim. One possibility is building massive space stations, self-sustaining habitats floating beyond our solar system, carrying thousands or even millions of people. But surviving in deep space would require immense resources, energy, and protection from cosmic radiation. Another option is colonizing a nearby exoplanet. Proxima Centauri b, just 4.2 light-years away, is one of the closest Earth-like planets. However, with current technology, it would take thousands of years to reach it. To truly escape, humanity would need a breakthrough, perhaps in nuclear fusion, antimatter propulsion, or even warp drives. The biggest challenge is moving large populations. Unlike science fiction, evacuating billions of people is nearly impossible with today's spacecraft. Even if we could escape, where would we go? Could we ever build a civilization on a distant world? In the next segment, we'll explore the future of interstellar travel, what it would take to colonize another planet, and how humanity might evolve in deep space. With Earth doomed, the only way for humanity to survive is to leave the solar system. But how could we travel the vast distances between stars? Is interstellar travel even possible? Current spacecraft are far too slow. The fastest probe ever built, NASA's Parker Solar Probe, travels at 430,000 miles per hour. At that speed, it would still take over 17,000 years to reach the nearest star, Proxima Centauri. To escape and rebuild on another world, humanity would need a new kind of propulsion. One possibility is nuclear fusion propulsion. Harnessing the same energy that powers the Sun fusion rockets could reach speeds of 10% the speed of light, cutting the journey to nearby exoplanets down to just a few decades. Another theoretical idea is antimatter propulsion. By annihilating matter and antimatter, spacecraft could achieve incredible speeds, possibly reaching 50% the speed of light. But producing enough antimatter remains a challenge. The most ambitious concept is the Alcubierre warp drive. If space could be compressed in front of a ship and expanded behind it, the spacecraft wouldn't break the speed of light, it would move space itself. While this remains purely theoretical, some scientists believe it could one day be possible. Humanity might also create massive generation ships, self-sustaining space habitats where entire civilizations could live and evolve over thousands of years while traveling to distant stars. These ships would carry Earth's history, culture, and knowledge, preserving human civilization even if Earth were lost. But even if we could travel between stars, could we truly call another planet home? In the next segment, we explore the challenges of colonizing a distant world and what it would take to build a new Earth in the cosmos. Finding a new planet to call home may be the greatest challenge humanity has ever faced. But even if we reach another star system, could we truly survive there? The first obstacle is choosing the right planet. Scientists look for exoplanets in the habitable zone, the region around a star where liquid water can exist. But even if a planet meets this condition, it may still be uninhabitable due to extreme temperatures, radiation, or toxic atmospheres. Terraforming could be the solution. This means altering a planet's environment to make it more Earth-like. We might release greenhouse gases to warm a frozen world, build artificial magnetic fields to shield against radiation, or engineer microbes to generate oxygen. But terraforming is a process that could take centuries or even millennia. Another option is adapting ourselves instead of the planet. Genetic engineering and cybernetic enhancements could allow future humans to survive in alien environments. Advanced technology may help us build self-sustaining domed cities or underground habitats on hostile planets. But there are social challenges too. A new civilization on another world would need laws, governments, and a sustainable way of life. How would society function without Earth's resources? Would we remain united, or would distant colonies become independent over time? Surviving on another planet is about more than just technology. It's about adapting to an entirely new way of life. In the next segment, we'll explore the future of humanity in deep space and whether we could truly thrive among the stars. Humanity has left Earth behind. We have traveled beyond our solar system and established a presence among the stars. But what happens next? Can we truly thrive in deep space? Surviving in space presents extreme challenges. Cosmic radiation, microgravity, and the vast emptiness create an environment hostile to human life. Future space colonists would need advanced shielding, artificial gravity, and new ways to sustain food and water supplies. One possibility is the creation of O'Neill cylinders, massive space habitats that simulate Earth-like conditions. These rotating space stations could house millions of people with artificial landscapes, weather systems, and even oceans. But the biggest question is, how would humans evolve in space? Without Earth's gravity, would our bodies change over generations? Would we become taller, weaker, or even develop new biological adaptations? Some scientists believe future humans could look vastly different from those on Earth, shaped by the unique conditions of space living. Another challenge is the long-term survival of human culture. How would language, government, and society evolve in isolated space colonies? Would distant human settlements remain connected to Earth? Or would they develop new cultures and identities, eventually seeing Earth as just an ancient homeworld? In the next segment, we explore the most mind-bending question of all. Could humanity one day transcend biology and become a spacefaring civilization that merges with technology? Is the future of our species destined to go beyond flesh and blood? As humanity expands across the cosmos, technology will evolve alongside us. But could we one day merge with machines, transcending our biological limits? One possibility is cybernetic enhancement, integrating technology into our bodies. Future humans may have advanced neural interfaces, allowing direct communication with artificial intelligence. Enhanced vision, strength, and cognitive abilities could redefine what it means to be human. Another idea is mind uploading. Some scientists speculate that consciousness could be transferred into a digital form, allowing humans to exist beyond physical bodies. If we become digital beings, we could travel the universe as streams of data, inhabiting robotic or virtual bodies at will. Artificial intelligence may also play a key role. Could AI help us govern vast space colonies? Would future humans and AI merge into a single entity, creating a new form of life? However, merging with technology raises ethical and philosophical questions. Will we still be human? Would societies divide between those who enhance and those who remain purely biological? How far is too far? In the next segment, we explore the final frontier of human evolution. What happens when civilizations reach the ultimate stage of cosmic advancement? Could we one day become an intergalactic species, shaping the very fabric of the universe itself? Humanity has reached the final frontier. We have conquered space, merged with technology, and expanded beyond our solar system. But what comes next? Could we one day evolve into an intergalactic species, shaping the universe itself? Some scientists believe that civilizations eventually reach a point where they harness the full energy of their stars, becoming what is known as a Type 2 civilization on the Kardashev scale. But even this may be just the beginning. A Type 3 civilization could control energy on a galactic scale, reshaping planets, stars, and entire solar systems. Could humanity one day reach this level? Beyond technology, our very nature might change. If we merge with AI or transcend biology, we may no longer be bound by human limitations. We could exist as digital consciousness, spreading across the cosmos at the speed of light, living inside vast megastructures, or even within the fabric of reality itself. But this future raises profound questions. Would we still be human in any recognizable way? Would we be explorers, creators, or something entirely new? And if other civilizations have already reached this stage, why haven't we seen them? Could we be the first, or are advanced beings out there, watching us, waiting for us to join them? Perhaps the greatest challenge isn't just reaching this stage, but surviving long enough to do so. Civilizations may face existential threats, wars, resource depletion, or self-destruction that prevent them from advancing. This idea, known as the Great Filter, suggests that most intelligent life never makes it past a certain stage. If we hope to reach the stars, we must overcome not only technological limitations, but also the challenges of survival, unity, and progress. What kind of future will we choose? And will we be the ones to unlock the mysteries of the cosmos? Or will we vanish like countless civilizations before us? In the final segment, we take a step back and reflect on everything we've explored. What does the future hold for humanity, and what role will we play in the grand cosmic story? As humanity ventures beyond our solar system and begins its journey across the cosmos, we face the ultimate question: what is our final role in the universe? Will we merely explore, or will we shape reality itself? Many scientists speculate that if a civilization survives long enough, it may reach a point where it can manipulate the very laws of physics. Could we one day control gravity, space-time, or even create entire universes? Some theories suggest that civilizations advanced enough could engineer artificial black holes as energy sources, or even simulate entire realities within quantum computers. But perhaps the most profound question is whether humanity has a purpose in the grand design of the cosmos. Are we alone, or are we just one of many species scattered across the stars? If we are alone, do we have a responsibility to preserve life and intelligence? And if other civilizations exist, will we be allies, competitors, or something else entirely? The greatest challenge of all may not be technology or survival, but wisdom. Can we learn to evolve beyond our conflicts and divisions to embrace the true potential of a spacefaring civilization? Will we create utopias among the stars, or will we repeat the mistakes of history on a galactic scale? At the end of this journey, we must ask ourselves, what will be humanity's legacy? Will we fade into the vastness of space, or will we become the architects of an intergalactic future? In the final segment, we step back and reflect on all we've explored, from the power of stars to the fate of civilizations. What will the future truly hold for us? And how will our story be remembered in the grand history of the cosmos? We have journeyed through the vastness of space, explored the mysteries of stars, and imagined the future of humanity beyond Earth. But as we reach the final chapter of this exploration, one question remains: what will our destiny be? Throughout history, humanity has faced countless challenges: wars, extinctions, and revolutions. Yet we have always endured, pushing the boundaries of knowledge and innovation. If we continue to evolve, we may one day colonize other planets, master interstellar travel, and perhaps even unlock the deepest secrets of the universe. But with great power comes great responsibility. Our future is not guaranteed. We must overcome the obstacles of war, division, and environmental destruction if we are to survive long enough to reach the stars. Every choice we make today shapes the road ahead. Perhaps the greatest realization is that we are not separate from the universe. We are a part of it. The atoms that form our bodies were forged in the hearts of ancient stars. We are the universe experiencing itself, capable of shaping reality in ways no other species has before. So as we gaze up at the night sky, we must ask, will we be the explorers who reach new frontiers, the architects of civilizations among the stars? Or will we fade into history, another lost species in the endless march of time? The future is unwritten. The story of humanity is still being told, and it is up to us to decide how it will end.